Question 25a. Three spherical objects of uniform mass distribution lie along a straight line as shown below. Calculate the distance x at which the resultant gravitational force on the object labeled M is zero. So here you have three spherical objects. I will label them as 1, 2, and 3. Mass of object 1, which we will call M1, is 4m. For object 2, M2 is m. For object 3, M3 is 9 times capital M. The distance between object 1 and 2, which we will call R12, is x. So we write R12 as x. Distance between object 1 and 3 is 10 centimeter, which you can write as 0.1 meter. And the distance between 2 and 3 will be 0.1 minus x. As the total distance from 1 to 3 is 0.1, a part of that distance is x, so the other part will be 0.1 minus x. I will write this distance as R32. We need to find x such that the net gravitational force acting on mass m is equal to 0. Now there are two forces acting on mass m. First, the gravitational force of attraction because of object 1. And object 1 will try to pull the mass m towards left. We call this force F12. Then the gravitational force of attraction because of object 3. And object 3 will try to pull mass m towards right. We call this F32. And if the net force on object 2 has to be 0, that means these two forces must be equal in magnitude and opposite in direction. So we can write for their magnitude as F12 equals F32. Now we know the force of gravitational attraction between two masses can be given as capital G M1 M2 over square of the distance between them. So R12 squared. We do the same thing for F32, capital G M3 M2 over R32 squared. Now let's substitute the values. Capital G M1 is 4 times capital M. M2 is just small m over the square of distance between them, which is x squared, equals capital G. M3 is 9m. M2 is just m over the square of distance between them. So distance between them is 0.1 minus x squared. Now let's cancel off the common terms. G and G will cancel. M and M here will cancel. And then write whatever is left. We have 4 over x squared equals 9 over 0.1 minus x squared. Then we take the square root before we solve further. Square root of 4 is 2. Square root of x squared is just x. Square root of 9 is 3 over 0.1 minus x. Then we will cross multiply to solve for x. So 2 times 0.1 minus x equals 3x. So that gives you 0.2 minus 2x equals 3x. Now move negative 2x to the other side. So it will give you 0.2 equals 3x plus 2x. So 0.2 equals 5x. Now divide by 5 to find the value of x. We get x equals 0.2 divided by 5. That gives you the value of x to be equal to 0.04 meter. Or you can write x to be equal to 4 centimeter. So the net gravitational force on mass m will be equal to 0 when you place it at a distance of 4 centimeter from the first object. Question 25b. Three spherical objects of uniform mass distribution lie along a straight line as shown below. Calculate the distance x at which the resultant gravitational force on the object labeled M is 0. So again here you have three objects. I will call them object 1, 2, and 3. Mass of object 1 is equal to capital M. For object 2, it is small m, whereas for object 3, it is 16 capital M. Distance between object 1 and 2, we will call it R12, and R12 is equal to X. Distance between object 1 and 3 is 10 centimeter, which you can also write as 0.1 meter. So the distance between object 2 and 3 will become 0.1 minus X, as if the total distance is 10 centimeter and a part of it is X, the other part has to be 0.1 minus X. We will call this distance as R32. So we write R32 to be equal to 0.1 minus X. We need to find at what distance X must we place mass 2 such that the resultant gravitational force acting on it is equal to 0. So here there are two forces acting on mass 2. First, the gravitational force of attraction because of mass 1, and mass 1 will try to pull mass 2 to the left, and we can write this force as F12. Then we have gravitational force of attraction because of mass 3, which will try to pull mass 2 to the right. We will write this force as F32. And if the net force on mass m has to be 0, that means the magnitude of these two forces must be equal and they must point opposite in direction. So I can write for their magnitude, F12 must be equal to F32. We know the gravitational force of attraction between two masses is given as capital G, m1, m2 over square of distance between them. So R12 squared. Write the same thing for the second force, capital G, m3, m2 over R32 squared. Now let's substitute the value. Capital G, m1 is capital M, m2 is small m, distance between them is x squared equals capital G, m3 is 16m, m2 is small m, distance between them is 0.1 minus x squared. Now cancel off the common terms. I cancel G, m, and small m. Then we write whatever is left. Here, all the terms are cancelled, so we get 1 over x squared equals 16 over 0.1 minus x squared. Now take the square root on both sides before solving further. So 1 over x equals square root of 16 is 4 over 0.1 minus x. Now we cross multiply to solve for x. We get 0.1 minus x equals 4 times x. Then we move this minus x on the other side. You get 0.1 equals 4x plus x. So we have 0.1 equals 5x. Now divide by 5 to get x. We will have x equals 0.1 over 5. That gives you 0.02 meter. Or you can write x as 2 centimeter. So when you place the small mass m 2 centimeter from the first object, that is where the resultant gravitational force on it will be equal to 0.